Let's learn how to solve absolute value inequalities. Let's solve the following inequality for x and put our answer in interval notation. If the absolute value is less than or equal to 9, that means what's inside the absolute value is between -9 and 9. In other words, we're going to use the following fact to help us. That the absolute value of y less than or equal to a means that -a is less than or equal to y is less than or equal to a. Let's apply that here. Namely, -9 is less than or equal to 5 minus 2x is less than or equal to 9. Now remember, when solving this type of compound inequality, we can work with all the parts at the same time. So let's start by subtracting 5 everywhere, which gives us -9 minus 5 is less than or equal to 5 minus 5 minus 2x, which is less than or equal to 9 minus 5. Or -14 is less than or equal to -2x is less than or equal to 4. And now let's divide everything by -2. However, remember, when we divide by a negative, we better flip or reverse the direction of both of these inequalities. Which gives us 7 is greater than or equal to x is greater than or equal to -2. Which we usually write in the other direction. -2 is less than or equal to x is less than or equal to 7. Let's look at this on the number line. Let's say this is -2 and this is 7. X is greater than or equal to -2. So x can equal -2. And then we go to the right. However, x has to be less than or equal to 7, so we stop here. And we're asked to put our answer in interval notation. Therefore, our answer would be close bracket, because we want to include -2, up to 7. Again, close bracket, because we want to include 7. All right, let's look at another example. Let's solve this inequality and again put our answer in interval notation. Now the difference here is that we have greater than rather than less than, like the last example. Now if the absolute value is greater than 1, then what's inside the absolute value is either larger than 1 or smaller than -1. In other words, we're going to use the following fact to help us solve this problem. That the absolute value of y greater than a means that y is greater than a or y is smaller than -a. And this is what we're going to apply here. And this gives us that 3 plus 2x is either greater than 1 or 3 plus 2x is smaller than -1. And now when solving this type of compound inequality, we work with each side separately. So let's start with this first inequality here. We'll bring the 3 to the right or subtract 3 on both sides, which gives us 2x is greater than 1 minus 3 or 2x is greater than -2. And now dividing both sides by 2, we get x is greater than -1. And what about this second inequality? Again, we'll bring the 3 to the right-hand side, which means 2x is less than -1 minus 3, or 2x is less than -4. Again, dividing by 2 gives us x is less than -2. And since these inequalities are joined by the word or, then the solution is all x values that make at least one of these true. Let's look at this on the number line. Let's say that this is -2 and this is -1. Greater than -1, we do not want x to equal -1, so we put an open circle. Greater than, we go to the right. X less than -2. Again, we put an open circle because x cannot equal -2. Less than, we go to the left. But again, we're asked to put our answer in interval notation. And doing this gives us our answer of -infinity up to -2, open parenthesis because we do not want x to equal -2, union, again, open parenthesis, -1 up to infinity. And this is how we solve absolute value inequalities. Thank you, and we'll see you next time.